Alright, so today we're working on our gears, pulley drives, and sprocket and chain systems. This first video will just be the gears problems, 1 through 9. First problem says we have a simple gear train composed of 3 gears. Gear A is the driver, has 8 teeth, gear B has 24, and gear C has 16. So part 1 wants us to draw this. So we have 8 teeth, 24 teeth, 16 teeth. Instead of drawing the teeth, just write what number of teeth there are in there. Makes your life so much easier. This was gear A, B, and C. Gear A was the driver or the input. Make gear C the output. Okay, part 2, if the output at C, what is the gear ratio? The gear ratio is just number of teeth over number of teeth, and it's always out over in except for the speed. And so this is just going to be 16 teeth over the 8, and we're going to get a gear ratio of 2. Okay, so now if gear A rotates at 60 RPM, so this is gear A, so this is my omega, and it's the in, is equal to 60 RPM. How fast is gear C rotating? So we're looking for the omega out. That's my unknown. We know my gear ratio is still 2, because that's what we solved, and it's the same gear train. So this is what we're looking for at C. So we know my gear ratio equation is the ratio of angular speed over angular speed. This one is in over out. If we solve this for the output that we're looking for, we get that's the input angular speed over the gear ratio, which is going to be 60 RPM over 2. So my answer is going to be 30 RPM. Okay, and then the last one, if the output of torque at gear C is 150 foot-pounds, what is the input torque? Okay, so now gear C, the torque out is 150 foot-pounds. At A, the torque in, we don't know. The gear ratio is still 2. So it's basically the same setup we just did, but now with torques. Okay, so the ratio of torque over torque, it's out over in always, except for the angular speed. We're going to solve this for torque in, because that's what we're looking for. So it's just torque out over the gear ratio, which is 150 foot-pounds over 2, so my answer is going to be 75 foot-pounds. There we go. There's 1 through 4. Okay, let's look at the next set. We have a compound gear train. Okay, it's composed of 4 gears, A, B, C, and D. A has 10 teeth and meshed with B. B has 20 and shares a shaft with C. It has 16. Gear C is meshed with D. The output, they don't tell us how many teeth, and tells us how much torque and speed that we put into at gear A. So number 5 says sketch all this. Okay, so we're going to have gear A. And gear A had, what, 10 teeth? So N equals 10. And then gear B, which was 20, so it's a big guy, bigger. B. And then C is on top of, so this is N of 20 teeth. And gear C, maybe I should have done him in a different color. Let's do pink so we can keep track of the 2 different gear trains. Okay, so C had 16 teeth, right? And then gear D, and we don't know D. He didn't tell us. Well, pink's running out. D has question number of teeth. Okay? And then it says that the power supplied, so the torque at gear A, I probably should write it on this side because A is over here. The torque in is 100 foot-pounds, and the speed in at A is 1600 RPM. Okay, and then 6, it says the necessary torque output for the system is 500 foot-pounds. What should the gear ratio of the system be? Well, we know the gear ratio is a ratio of torques. Okay, it's always out over in, except for the angular speed. And so they gave us the output torque is 500 foot-pounds, and the input torque was 100 foot-pounds, and so we get 500 over 100, or just a gear ratio of 5. 7, it says with a system torque output of 500 foot-pounds, right, what we have, how many teeth should gear D have? Okay, so when we're looking at teeth, we have to look at the overall setup. We know my gear ratio was equal to 5, and we know my gear ratio is also equal to number of teeth, okay, at the output over number of teeth at the input. But because it's not a single a single gear train, but it's a compound gear train, we can't just do this straight through, right? We couldn't put that there's 10 teeth in and try to figure this out and say there's 50 or something coming out of there. Okay, so we have to look at this. We have to multiply these gear trains together, right? So it's the in, out of the first part, and then we're multiplying that times the second, because remember, gear ratio total is equal to the gear ratio of the first part times the gear ratio of the second part. And so that's what we're doing here. We're setting this up. Gear ratio total is equal to gear ratio of the first part times the gear ratio of the second part. Okay. Remember the in out up here, this is B, right? So I'll do this in a completely different color. Sorry, it's getting a little confusing here. So this is B, and this was A, right? And then this over here, this in out is D, and this over here is C. So that's what we're looking for teeth. So just trying to help you keep track of stuff. Okay, so when we put in all our numbers, we're going to get this, that the in out, that's the B over A, so it's going to be the 20 over 10 times the, we don't know, okay, so D, we'll just call it D, over 16, and all that's going to equal 5. And now we just have to solve for what D is. So we're going to multiply 5 times the 16, okay, 5 times 16, that gets rid of that, okay, and then we're going to multiply that again by the 10, get rid of that, and then we're going to divide all that by the 20 to get rid of that, and now we have that equals to D. And now we can just put all that in our calculator. So 5 times 16 times 10 divided by 20, and we get 40. Okay, so the number of teeth we should have coming out on D is 40 teeth.